So in this lecture, we're going to start looking at bacteria. Now, there are a lot of bacteria out there, and so these next couple chapters group it into gram-positive bacteria, gram-negative bacteria, and then our kind of unusual bacteria that they get their own chapter. And so we're going to start with our gram-positive bacteria. Again, these are all the bacteria that can become pathogenic. They can cause problems for us. Now, on this first slide, and I'm like, may look a little familiar or it will, and I'm like, from our lab. I'm like, we're using this exact same type of flowchart for helping ID out various types of gram-positive cocci bacteria in our lab. And I'm like, and so whether they are we group them or separate gram-positive bacteria based on shape, cocci versus rods. And then of the cocci, we do a catalase test, which we're doing in lab. And if they're catalase positive, we know it's some type of Staphylococcus bacteria. If it's negative, it's either streptococcus or enterococcus. These are the main bacteria that are cocci shaped. It's also in their names. And I'm like, but these are catalase negative. And then in lab, again, we set up coagulase tests to help us narrow down the actual species of the Staphylococcus bacteria. There's a few other tests we can do on gram-positive rods, but for our lecture, we're going to kind of start looking at this chart, and we're going to work our way from the left side to the right side. So we're really going to start focusing on gram-positive cocci to begin with. Alright, so we're going to start with Staphylococcus. Sorry if I have to pause this PowerPoint when I cough. We're going to start with on the left-hand side with our Staphylococcus genus. So these are catalase positive and coagulase positive. Well, not always coagulase positive, but our first bacteria that we will discuss will be. Now, Staphylococcus in general are usually part of our normal flora. So normal members of our human microbiota. However, they can become opportunistic pathogens. And I'm like, usually if they get somewhere where they're not supposed to be, or they start to become overgrown. Characteristics when we gram stain Staphylococcus, they are gram-positive, that's the whole chapter. They're all cocci. Again, it's part of its name. And Staphylococcus like to hang out usually in clusters. Now, we've seen some of these already in our lab, and I'm like, because a lot of the bacteria that grows on you are a type of Staphylococcus. But they are all catalase positive, the one test we do in lab. Now, this particular genus is also tolerant of salt, which is why it can grow on the mannitol salt plate in lab. It's tolerant of drying out, it's tolerant of radiation, it's tolerant of heat. So it can survive on environmental surfaces, such as tables, for a long period of time. Now, two common Staphylococcus bacteria that can cause disease, and usually it's only when they get past that first line of defense, are Staphylococcus aureus or Staph aureus and Staphylococcus epidermidis. Now, the more virulent strain is the Staphylococcus aureus. More virulent meaning more likely to cause an infections. Now, this particular bacteria, it only takes a few hundred of them to get past that first line of defense, and it will cause an infection. So I'm like, it doesn't take much for these, and I'm like, to cause infections. Now, it also depends on the site of infection. It depends on what you'll end up getting. Is it going to be some type of skin infection? Is it going to be a bone infection? Is it going to be some type of pneumonia? And I'm like, it really just depends on the site of infection. Staphylococcus epidermidis is generally just a normal skin flora. We have it all over our hands, all over our skin. But it can cause opportunistic infections if it gets in with IVs, where you've got those open wounds, or some type of prosthetic device, or some type of catheter. And I'm like, it can now get inside the body where it's not supposed to be and become an opportunistic infection. But it is less likely to cause disease, so we're going to focus mostly on the Staph aureus bacteria. Now, Staph aureus has a whole bunch of virulence factors. So these are all things that help the bacteria cause disease. So it's good for it, bad for us. And the very first thing that it has, and I'm like, we'll discuss, there are very structural things that Staph aureus has. And the first thing is that it has protein A. Protein A, a little orange circle here, it coats the cell's surface. And I'm like, so it actually coats that bacteria. It's a big gram-positive cocci there. And I'm like, it coats the surface, and one, it interferes with our humoral immune response. being able to recognize it and attach to it correctly with antibodies. It also helps inhibit opsonization and the protein complement cascade, which means antibodies aren't going to be able to code it correctly and target it for phagocytosis. So I'm like, good for it because it can survive, bad for us. It also has an enzyme on the outside of it, so it's called bound coagulase because it's an enzyme attached to it. And what coagulase does, it converts fibrinogen to fibrin, and when it does this, it actually forms a clot. Now, here's the coagulase, here's the bacteria. It forms a clot, and the bacteria can now hang out and hide, and I'm like, from our immune system in these clots. And then it also has a capsule to it, and I'm like, the capsule helps inhibit phagocytosis, and so it can't get eaten by this big old white blood cell. And it also helps it attach to surfaces, because again, bacteria need to attach and find a home before they can start to replicate. So these are some structural things that it has. That's good for it, bad for us. Some enzymes that it has, that again, good for it, bad for us. It has a cell-free coagulase. So it's still a type of coagulase, still basic idea. And I'm like, you can still form clots from hiding. However, this can actually trigger blood clotting. Now, why the blood clotting is good, and I'm like, for it, and I'm like, one, it can hide in some of these blood clots, but it actually causes a detrimental effect to the human body, which allows the immune system to thrive. It's one of those, if it can damage our body, usually that means it's going to be thriving. It has another enzyme, again, these are enzymes, they all end in ACE. It has Staphylococci, which then helps dissolve blood clots so that it can free itself. And so, yes, it's at some point going to not want to be hiding in that blood clot. And I'm like, and so it can break down the blood clot and then go to wherever it needs to now go, infecting new areas. It can make an enzyme called hyaluronidase. Hyaluronidase helps break apart cells. So it enables the bacteria to start spreading between cells now. And so instead of having two cells, epithelial cells, held together, it helps break that down and provides an entry source for bacteria to get in. It has another enzyme called lipases. Again, anything lipid, we're talking oil. This allows the bacteria to grow on our skin and in the oil glands. So Staph aureus really is found inside those oil glands, those sebaceous glands. And then it has an enzyme called Betalactams, which breaks down the whole class of drugs called Betalactams. This is that whole class of drugs, including penicillin, that's main job is to break apart that cell wall, make it a weak cell wall, NAMs and NAGs don't attach correctly. Whole class of drugs that do that. Well, this is an enzyme that breaks down anything that resembles a beta-lactams drug, which means penicillin or any other beta-lactams drug is not going to work against this bacteria. This bacteria can naturally break down that whole group of antibiotics. This is my little reminder of beta-lactam drugs. Those NAMs and NAGs that normally should be held nice and tight together, beta-lactam drugs prevents that from happening, and the bacteria fall apart. They have a weak cell wall. Well, if you've got the enzyme that breaks down beta-lactams, such as penicillin and methicillin, and I'm like, your cell wall will be structurally sound. And then another group of virulence factors that Staph aureus has, it has a bunch of different types of toxins that it makes. One, it has a group of cytolytic toxins, which it says in lysine cells. It disrupts the cell membranes, usually of white blood cells. So it actually starts to break down white blood cells. The white blood cells are there to try to get rid of bacteria, to eat up bacteria, to target them for destruction. Well, the bacteria is like, we don't want to. We want to kill those bacteria. We want to kill those particular white blood cells. They can also use it, and I'm like, to not just get rid of or kill white blood cells, they can also use it to kill other cells and try to penetrate in. So if you've got a cell that's preventing the bacteria from getting in, we can start to kill those cells, and now we have entry source. It's a great toxin to have if you're a bacteria. You can kill cells, and I'm like, one, cells that normally would want to kill you, or cells that prevent you from getting in. It also has exfoliative toxins. that cause the skin to slough off. And as your skin is sloughing off, your skin is that first line of defense. If your skin is starting to slough off, and I'm like, you're losing some of that first line of defense, and it provides this window or opening for these bacteria to get in. It also produces another toxin called the toxic shock syndrome toxin. Now, we'll talk about the toxic shock syndrome shortly when we start getting into some other bacteria, because other bacteria also creates this particular toxin. But yes, it causes toxic shock syndrome. And the last toxin it produces is enterotoxins. Anything with entero refers to intestines. And I'm like, so this is a toxin that affects the intestines, usually causing symptoms associated with food poisoning, so diarrhea and vomiting. Now, it's that food poisoning, that enterotoxin. And I'm like, when you ingest bacteria that produce a toxin, it's called intoxication. It's not the bacteria that are causing the food poisoning symptoms. It is the toxin that the bacteria are making that is causing those food poisoning symptoms. So I'm like, it can cause, the disease, food poisoning disease. It can also cause various types of skin diseases, cutaneous diseases. One is the scalded skin syndrome. The scalded skin syndrome is when your skin starts to turn extremely red. You usually get blisters and it starts to peel off, just like if you burnt your skin. Again, this is the bacteria causing that sloughing off of the skin. I should make note, and I'm like, this is a poor little baby that, yes, has a Staph aureus infection, that the skin is sloughing off. That's bad for the baby because now that bacteria is trying to get into the body. It causes impetigo. Impetigo is kind of red pustules that also have pus associated with them. And it causes folliculitis, which is an infection of the hair follicle. Again, these love to live in the sebaceous glands, which are associated with the hair follicles. So this is a lot of times is where you're going to see that inflammation happen because you've got lots and lots of bacteria growing. Now, some other diseases it can cause are systemic diseases, which means it's getting into body systems. It's getting into deeper tissues of the body. It's affecting systems in the body. It is less common, thank goodness, but it's affecting those deeper tissues. Now, examples when it gets in and affects these deeper tissues, one, it can cause that toxic shock syndrome because that toxin has now gotten into the blood, and it's going to produce fever, vomiting, rash, decrease in blood pressure. And I'm like, and there are various strains of Staphylococcus that produce this toxin. It can cause bacteremia. That's when you have not just the toxin in your blood, you have the bacteria is now in your blood. It can cause endocarditis. This is when you're going to have a damage to the lining of the heart. And 50% of those that have this inflammation of the heart lining end up passing away because of it. And it's an extremely fatal disease. And I'm like, if you've gotten, this severe to this point, it can cause pneumonia, which is an inflammation of the lungs. It can also cause osteomyelitis, which is an inflammation of the bone and bone marrow. A lot of times it's seen mostly in the vertebrae where you're going to get that bone marrow inflamed. Again, these are rarer, but they can happen. Sorry about that. Now, diagnosing someone for Staphylococcus, one, a lot of times they're going to culture it out. They're going to look for that gram-positive coccus bacteria on the microscope. They're also going to do a catalase test. If it's catalase positive, you know you're in that Staphylococcus genus. Treatment, and I'm like, one, clean and disinfect wounds. Methicillin is the top antibiotic of choice. However, some bacteria like Staph aureus are becoming resistant to methicillin, and vancomycin right now is our next alternative. Again, methicillin is the antibiotic that, as they're becoming resistant, this is where we're starting to get MRSA. It's the methicillin-resistant Staphylococcus aureus. Now, your best bet is just to not get a Staphylococcus infection, and the best way to prevent it is good hygiene, including washing your hands. So that was our gram-positive cocci, but there are catalase positive. Now we're going to flip over and start with catalase negative. I won't get through all of this. The rest on this listening, recording. The rest we'll get done in lecture. But we're going to look at that first catalase negative streptococcus bacteria. So streptococcus, they are gram-positive cocci. Again, everything in this chapter is gram-positive. Cocci is part of its name. They usually hang out in pairs and chains. Also, streptococcus usually are going to have a beta or an alpha hemolytic reaction. So you're going to see kind of that yellowing or greening if it's alpha, or you're going to see that complete clearing if it's beta. Now, there are quite a few streptococcus bacteria, but we group them based on their surface antigens. It's called a Landsfield grouping. All based on surface antigens, nothing you can physically see. And I'm like, but the two groups, although there's a group A, B, C, D, and then GF, I don't know what happened to the E. And I'm like, it's really only groups A and B that include human pathogens, so they're the only ones we're going to study. But I'm like, we're going to look at, I'm like, group A contains that bacteria we tested for in lab, Streptococcus pyogenes, but there's other bacteria in group A, and then group B includes a big Streptococcus bacteria called Streptococcus agalactiae. But we're going to start with the Streptococcus pyogenes in our group A Streptococcus bacteria. Now, it also has quite a few virulence factors. Again, these are things that allow it to cause disease. Well, it's good for it, bad for us. One is that it can help evade phagocytosis, because it, one, has this M protein on the outside of it that destabilizes complement proteins, which means complement proteins aren't going to be able to recognize, bind, and target for cell lysis. And I'm like, it also has a capsule on it. It's a slightly different type of capsule. It's a hyaluronic acid capsule, but it hides the bacteria. Our immune system can't always recognize this particular capsule and target it for destruction. It makes an enzyme called streptokinase. It's a Streptococcus bacteria. This helps break down blood clots. It allows them to spread through tissues easier if they can help break down any clotting, any thickening. It's almost like they're thinning stuff out. It also makes an enzyme called deoxyribonucleases. Yes, the same part of like DNA. And I'm like, there is DNA in any type of cell we have in our body, including white blood cells. And I'm like, and we've got lots and lots of white blood cells in pus. Well, this particular enzyme starts to break down those white blood cells by breaking down all the DNA, and it helps thin the pus, reduces that firmness of it, and it helps the bacteria spread to new areas faster. It also produces pyrogenic toxins. Anything pyro means generating some type of heat. So it's going to stimulate fever as well as rash, and it can cause you to go into shock. And it produces another factor called a streptolysins. This particular molecule can break apart or lyse red blood cells. And again, it breaks it down. And I'm like, it's part of the reason it causes beta hemolysis. And I'm like, but it breaks down the red blood cells. It can get the nutrients from them very, very easily. Now, Streptococcus pyogenes, although yes, it can cause strep throat, it's not the only thing it can cause. It's the most common disease that you may have heard of because of this bacteria, but can also cause scarlet fever. Now, I should note, the official term for strep throat is pharyngitis. It's the inflammation of your throat or inflammation of the pharynx. It can also cause scarlet fever. This usually follows pharyngitis or strep throat, so if you didn't get treated for strep throat, you just let it go. This usually includes still that inflammation of the pharynx, but it also includes a chest rash as well. And so you look red, you're going to have a fever, and scarlet fever. It can also cause pyoderma. These are pus-filled patches, and so you almost have these big inflamed areas on the skin that are pus-filled. And erysipelas, and I'm like, I forgot to put this in blue, but inflamed lymph nodes. So you're going to have swollen lymph nodes with this. Now, I put my little note on here, and I'm like, the thing above it are specific for Streptococcus pyogenes. The things below this, including the next one on the next slide too, include Streptococcus pyogenes as well as other bacteria in that group A Streptococcus bacteria. Again, the ones that have the A antigens. So it's not only Streptococcus pyogenes, it's Streptococcus pyogenes as well as other group A. And the one it can cause streptococcal toxic shock syndrome. Another type of toxic shock syndrome. It's a multi-symptom infection, can cause organ failure, shock, and even death. It can also cause necrotizing fasciitis, more commonly known as the flesh-eating bacteria, which always makes the news. It's rare, but it happens. And yes, a lot of the time, we can't kill it fast enough that you usually end up having to do some type of amputation and removal of that tissue. Now, I'm not going to click on this link, but I can put this link available for you. There was a professor right at UWL. He was the fungus, the mycology professor, that he ended up actually getting flesh-eating bacteria on his foot. And so he documented it. Of course, if you're a teacher, you're going to document that. He put that on there so you can see some of his pictures and how bad it got on his foot and how long it took for it to end up being healed. Now, here's a continuation of other group strep A diseases, which could include Streptococcus pyogenes. The first one is rheumatic fever, which means that this particular bacteria, the strep bacteria, is going to damage your heart valves. It gets to your heart, damaging your heart valves, damaging heart muscles. It's an autoimmune response against the heart antigens, that this particular bacteria is actually targeting the heart. And doing damage, and our immune system, because of that, starts to damage our heart. And so we end up having all of this damage from the bacteria on our heart. So I kind of looked this, yes, a sore throat, if you had strep throat, it can lead to a broken heart. Now, and a famous actor, Bill Paxton, just this last fall, ended up dying because of this. He ended up having to have heart valve replacement surgery because as a kid he had rheumatic fever. And and he knew it. There was a podcast and or a recording of him talking about how he had to have valve replacement surgery because of this. We ended up dying from the surgery, unfortunately. But it's not, it can happen. And these days we seem to treat it faster and more often than before, and so there's less occurrences of it, but it can damage the heart valves. It can also accumulate and get into the kidneys, more specifically the glomeruli, in the little nephrons and the glomeruli. And all of the antigens this actual bacteria accumulates inside of there. It can cause inflammation, hypertension, it can lead to a decreased urine output, and can cause kidney damage. You've got inflammation of the kidneys and kidney damage. And so it's not just a heart, it's not just the throat, it's not, it's lots of parts of the body that Streptococcus bacteria can affect. Now, when you're trying to diagnose someone for Streptococcus pyogenes, the easiest way is that rapid strep kit. This exact same kit that we have up in lab is the exact same kit they have in the hospitals and in clinics. If we're going to culture the specimen out as we try, it's going to show up as gram-positive cocci, short chains and pairs. You're going to see that beta hemolysis. It's going to be catalase negative. And if we wanted to really ID it down, it's going to be sensitive to the antibiotic bacitracin, which means if we put a little antibiotic-soaked disc of bacitracin on this bacteria, they would be affected by it. And the best treatment for this particular bacteria is penicillin. It's the number one choice now, or some type of derivative of it. Now I'm going to end there, and we'll continue on with Group B Streptococcus bacteria in lecture.